Welcome to Stewart Science. I apologize for the quality of this video. It was made well after my other videos, and so I didn't have all the materials and things to make it look as good or edited the same way I did my other one. So I really wanted to just give an overview here of F6, which is friction and calculations with it. So if you were in class, we did two small labs where we changed the surface that our weight was sitting on, and we pulled it with a force probe to see which surface gave us the most friction. What you should have seen is that different surfaces had different strengths of pulling, even if there was the same weight on top. And so the sandpaper was probably the stickiest of the surfaces, and then the metal was after that, and then the wood on wood had the lowest friction. So something about the surface and how grabby or grippy the surface is a contributing factor to friction. And so we called that the coefficient of friction, which don't get bogged down by that name. It's just how sticky or how grabby the surface is. I'll put it here. So for example, ice, not very sticky, low coefficient of friction. But sandpaper or rubber, these things grab really tightly and they hold a lot of friction. And so that would be a high coefficient of friction, which is that. It's a Greek letter, mu. And again, don't get bogged down in this. And so all of the other thing that mattered was how much force was downward on the surface, or how much force the surface is pushing up with, which we call that the normal force. So this is how much force is on the surface, which we call that N. And those two things multiplied together give us the force of friction. So you have this equation. Friction equals the coefficient, which is just how sticky it is, times the surface force, or the normal force. This is how hard things are pushing down. This is the surface, and this is the friction force you get. Now, let's talk units, because these two things, normal force and friction force, are both forces, which means they're measured in newtons, or just N. This one is the weird one, because it's technically newtons over newtons. It's a fraction, it's a ratio for how much of the surface force gets turned into friction. So if this was like 0.25, that means for every 1 newton of surface force, you get 0.25, or 25% of that, as friction. So this is newtons per newton, and then both of these are newtons because they're measuring a force. So let me just give you three very quick examples on this. The first kind would be finding this coefficient of friction. If I told you that the force of friction was 600 newtons, and the normal force, the force down on that surface, or the force up on the surface, is 2,400 newtons, then the only thing you don't know is that Greek letter, mu, which is the coefficient, the stickiness. So the question is basically asking, if it says what's the coefficient of friction, what percentage of that force do you get from this? And so all you got to do is solve it using algebra. Since it's multiplying, you undo that by dividing by 2,400. Divided by 2,400, and you get 0.25 equals the coefficient of friction. And this is either newtons over newtons for your unit, so that's blank 1, 0.25. Newtons divided by newtons, n over n, is your blank 2. It's your unit. If you also just typed none in blank 2, it would count that correct as well. Or no unit. That would be right. Because all it is a percentage. It's what fraction of that kind of force turns into that kind. what percentage of your normal force, what decimal of your normal force becomes friction. And so for whatever surface this is, it's 25% or 0.25. We need 2 more problems. If I ask you to find the force of friction, I'll give you these 2 things, the surface coefficient and the force. So I'll say the normal force might be 2,000 newtons, and let's just use the decimal that we had from the last question, which is 0.25. So the question is going to say the coefficient of friction is this, the normal force is this, what's the frictional force? And so the equation just tells us if I give you a coefficient and a normal force, you just multiply them. No algebra needed. Just go to your calculator. This times this equals 500. And the unit for force is always newtons. N. That's it. Okay, second to last question. Or sorry, last question. If I'm asking you to find the normal force, I'll give you the friction and the coefficient. So the friction in this case, we'll call it 1,400 newtons as the force of friction. And let's say I have a really, really sticky surface, like sandpaper or rubber, things that just grab on to what they are touching. And that coefficient of friction is 0.8 newtons per newton. Newtons per newton. And I ask you, what's the normal force? Now all I have to do is a little tiny bit of algebra, because since it's multiplying here, you undo that by dividing. To get the n by itself, divided by 0.8. Divided by 0.8, go to your calculator and type that in, and you get 1,750 newtons equals n. The normal force is 1,750 newtons. So, in summary, I have 3 pieces of information. Friction force in newtons, coefficient in newtons per newton, that's how grippy the surface is, and surface force, also in newtons. So if I'm asking you what is the force, either one, the unit is n, newtons. If I'm asking you what is the coefficient, if you see those magic words, then it's n over n. Or again, you can write no unit or none. As always, this is Mr. Stewart Science. Keep learning no matter what.